Okay, so today or this week we are moving on to the next section of chapter 9. So we're on 9.4 now. And the title is Multiplying and Dividing Radical Expressions. And we've actually already talked back a couple lessons ago about how to multiply and divide radicals. So it really starts out with just using stuff that you already know. In fact, if you look at the lesson, it starts on page 468. So this is where I'm at if you want to follow along in your book. And you'll see if you look at it, it starts out with examples. It doesn't even talk about anything new. And the reason why is because you already know what you need to know. You already know the rules for multiplying and dividing radicals. And last class we reviewed that again, and then we talked about how to add and subtract radicals. So we're really just reviewing to start this lesson off with. Now we are in a few minutes going to get to something new, and we're going to talk about a new word called conjugate and how to use a conjugate to rationalize a denominator. So that's really the only new thing that we're going to talk about today. So we're going to start by just looking at some problems that you should pretty much already know how to do. If you look at example 1, part A, very first one, it says find the product and simplify, and it's the square root of 6 times the square root of 3. So we have actually the last 2 lessons reviewed how to multiply 2 radicals like this, but let's review again. The rules for multiplying radicals is that the root has to be the same. As long as your root is the same, you're good to go. All you have to do is multiply the numbers underneath. So our root is the same here. These both have a root of 2. So I just leave the root the same. This is also going to be a square root. And then I just multiply the numbers underneath. So 6 times 3 is going to be 18. And then don't forget, once you've done the multiplication, you always want to simplify if you can. So that's something else that we've learned how to do also in a previous lesson. So we're really just kind of taking all these skills that we've been learning the last couple weeks, and we're putting it all together. So, quick refresher on simplifying a radical. That's where you look for a factor of the number that's a perfect square. So 18 is not a perfect square itself, but it does have a factor that's a perfect square. That's your 9. So we can rewrite 18 as 9 times 2, and then we break it apart, and we simplify each part individually. So the square root of 9 becomes a nice little 3 there. The square root of 2 we can't do anything with because 2 is not a perfect square and it doesn't have a factor that's a perfect square. So this is final answer. Okay, so you're just using your rules for multiplying radicals and then you are simplifying your answer. Part B, pretty much the same thing except that it's with a cubed root instead of a square root, but the rules work exactly the same way. So let's do that one real quick. It's the third root or cubed root of 5 times the cubed root of 16. Okay, so same thing. In order to be able to multiply these together, I need to have the same root. I do. They're both a cubed root. So I'm just going to leave the root alone. It stays the same. And then I just multiply the numbers underneath. I believe 5 times 16 is 80, but I'm going to just double check and make sure. Yes. Okay, so this becomes the cubed root of 80. Now, you want to try to simplify this if you can. If you remember back, I think it might have been 2 lessons ago, we talked about how to simplify radicals, and we talked specifically about how to simplify a radical, something that's other than a square root, like a cubed root. So if you're trying to simplify a cube root, you're going to look for a factor of the number that's a perfect cube. An example of that would be 8. 8 is a perfect cube because you can write it as 2 times 2 times 2. If you can write it as something times itself 3 times, then it's a perfect cube. So 8 is a very common perfect cube. And it's also a factor of 80. So what we want to do to simplify this is break 80 down into its factors of 8 and 10. And then we can break it apart also into the cubed root of 8 times the cubed root of 10. And then we're going to simplify each part individually. The cubed root of 8 we can do. That's just a 2. Okay, 2 times 2 times 2 is 8. So it's a nice perfect cube. Now 10 is not a perfect cube, and it doesn't have a factor that's a perfect cube. So what are we going to do with it? We're going to leave it alone, and we just bring it down. Okay, so we multiplied the numbers underneath, and then we simplified by breaking it apart into factors that were perfect cubes, like an 8, which becomes a 2. Okay, so both parts don't always simplify. Only one part usually simplifies, and then the other part just kind of comes down. All right, so this is just a lot of review of how do you multiply, how do you simplify, all that kind of fun stuff. When you get to example 2, we start getting to some things that look a little bit different from what we've already done. But it's still just using all of the same skills that you've already learned. So if you look at example 2, let's just look at example 2B, part B. This is example 2B. It's being multiplied by 4 minus the square root of 8 in parentheses. This looks like the distributive property, right? It looks like we need to distribute this. And you're right, that is exactly what you need to do here. You need to distribute. The only weird thing about this problem is that there's radicals in it. But do it just like you would do any other distribution. So we're going to multiply the square root of 2 times 4. That is going to need to be written like this. 4 square roots of 2. I know lots of you guys are going to look at that and say, oh, well, multiply the 4 and the 2 and write it as the square root of 8. But you can't. The 2 is under a radical, the 4 is not. So you can't multiply. They're not multipliable because one is under a radical and the other one isn't. So what you do is you just stick the 4 in the front and you write it as 4 square roots of 2. Now I'm going to bring down this minus, and I'm going to distribute the square root of 2 to the square root of 8. That's multiplying two radicals like we were just doing. The roots are the same, so you can multiply. You just multiply the numbers underneath. So you're going to multiply that 2 times 8. All right, so bring down the 4 square roots of 2. I don't see anything we can do with that to simplify it. I think that's as good as you're going to get with that. But we can simplify the square root of 16. That's going to become a 4. So this becomes 4 square roots of 2 minus 4. 2 times 8 is 16, and then take its square root. Now, this is another case where a lot of people are going to want to look at this and say, oh, well, let's try to combine that together. Don't try to combine this together. These are not like terms. You remember, when you're adding and subtracting, you have to have like radicals. And these are not like radicals. So don't try to combine that. Just leave it the way that it is. All right, let's take this even a step further and let's look at the next page over at example 3. You should know exactly what kind of problem example 3 is as soon as you see it. It should look very, very familiar to you. We have 2 radical 7 minus 4 times radical 7 plus 1. So this is what we call a 2 by 2 multiplication. You're multiplying 2 terms by 2 terms. This looks like a FOIL problem, right? Typical FOIL. Again, the only difference is that it's got radicals in it, but that's okay because you know how to work with radicals now. So just FOIL this the way that you would FOIL anything else. Multiply your first terms, your outside terms, your inside terms, and your last terms. So there's 4 multiplications to do here. Start with first times first. 2 radical 7 times radical 7. If that confuses you, here's one way that you can think of it. Remember that radicals have imaginary 1s in front of them, just like x's do. So multiply the like parts. 2 times 1 is 2. And radical 7 times radical 7 is just radical 49. They have the same root, so you just multiply the numbers underneath. Okay? That's your first times first. Now let's multiply our outside terms. That would be 2 radical 7 times 1. Anything times 1 is just itself. You could also think of it as 2 times 1 is 2, and the radical 7 just tags along. Now let's multiply the inside terms. Negative 4 times radical 7. Well, negative 4 times 1 is negative 4, and the radical 7 tags along. And then last times last is negative 4 times 1, which is a negative 4 or minus 4. Now you always want to take, once you've FOILed it out, you always want to simplify it as much as you can. I see a perfect square here, so I know there's something I can do with that. I also see some like radicals here that are combinable. Okay, so let's start by replacing this square root of 49 with a 7. If you're not sure what to do with the 2 and the 7, you multiply. So once you take the square root of 49, it becomes a 7. It's going to multiply with the 2 in the front and become a 14. Now from last class, we talked about how to add and subtract radicals. Remember that to add and subtract radicals, they have to be like. They have to have the same root and the same radicand. Well, these do. These are like radicals, so they are combinable. And the way that you combine them is you add or subtract the coefficients. So that's going to be your 2 minus 4 is negative 2. And then your radical tags along just like an x would. Remember, you combine just like you combine like terms. Add or subtract the coefficients, let the radical tag along, just like a variable does. And now let's bring down that minus 4 in the back here. I see one more thing that we can do. We can combine that 14 minus 4. So 14 minus 4 is going to become a 10. And then bring over that minus 2 radical 7. Don't try to combine these together. They're not like terms. Lots of people like to say, oh, 10 minus 2 is 8, and say 8 radical 7. You cannot do that. They are not like radicals. Don't try to combine them together. Okay, now there's a reason why we just talked about all of these types of problems. They're all going to come into play if you turn the page and look at page 470. It starts talking about conjugates. Now this is where we really get to the new stuff of the lesson. Now if you've had Algebra 2, then you should know all about conjugates. If you have not had Algebra 2, then this is probably something new to you. So at the very top of page 470, it gives you a definition of what a conjugate is. It says the expressions, it gives you an example. The expression 3 plus radical 6 and 3 minus radical 6 are called conjugates of each other. Notice that they differ only in the sign between the terms. So conjugates look exactly the same as each other, except that the signs in the middle are different. One is going to be a plus and one's going to be a minus. But other than that, they look identical. So these are conjugates. Now, why do we care about conjugates? The reason why we care about conjugates is because if you multiply them to each other, so in other words, if I set it up like this as a FOIL problem, and I FOIL these conjugates into each other, I multiply them together, what happens is the radical cancels out and goes away, and you're left with something without a radical in it. Now, why do we care about that? Well, if you look at the next page over at page 471, it talks about how to rationalize a denominator that has more than one term in it. So look over at page 471 now. It says to simplify a quotient involving radicals, you rationalize the denominator. So actually, I think maybe the last two classes, we've talked about rationalizing denominators. And we've talked about how if you have a fraction like this, with a radical in the denominator, in the bottom of your fraction, you have to get rid of that radical in the denominator. And the way you get rid of it is you rationalize it. And if it's just a single radical like this, you can just multiply it by itself. Because whenever you square a square root, you undo the radical and the radical goes away. Now, here's the problem. What if, rather than just a plain old square root of 2, what if this was a 2 plus square roots of 2 on the bottom? Just multiplying this by the square root of 2 is not going to get that square root to go away anymore. It won't work. You'll still have a radical in your denominator. So it gets a lot more complicated when you start adding things to that radical underneath. Now let's look at page 471 and read. It says to simplify a quotient involving radicals, that means a problem like this, you rationalize the denominator. For single term denominators, that means you just have a single radical in the bottom. You can use the rationalization process described in section 9.2. That's what we were just talking about, where you just take it and you multiply it by itself, and the radical goes away. To rationalize the denominator involving two terms, that means you have two things under here in the denominator. Multiply both the numerator and denominator by the conjugate of the denominator. So what you're going to do is, remember, you can get rid of a radical if you multiply it by its conjugate. So instead of just multiplying the radical by itself, if you have something like this, you're going to have to multiply it by its conjugate. And of course, you also have to remember that this is a fraction. So whatever you do to the bottom, you must also do to the top. So I know probably what I've said so far sounds a little confusing, but I think when I show you an example and I show you how it's done, it'll make sense. So let's just do one. Let's say we have 4 over 2 minus the square root of 3. This is example 6, part B. Okay, so if you look at this problem, obviously we have an issue, right? We have a radical in the denominator. That's got to be fixed. We gotta do something about that. So we want to rationalize this denominator, and just multiplying it by a square root of 3, multiplying the radical by itself, isn't going to work here because we have a number stuck in front of it. There's two terms here in the bottom. So what we have to do is we have to multiply it by its conjugate. Its conjugate is going to be 2 plus the square root of 3. Remember, you just rewrite the exact same thing, but you change the sign in the middle. And then, of course, whatever we do to the bottom, we also have to do to the top to keep the fraction balanced. So we're going to multiply the top and bottom of this fraction by 2 plus the square root of 3. Now, what we have now is a problem that needs to be simplified, and it looks an awful lot like the problems that we were just doing. This 4 needs to be distributed. Oh, we were just doing problems like that. And the bottom needs to be FOILed. We just did a problem like that too. So there's a reason why we just practiced all the problems we just practiced, so that when you get to this, you'll know what to do to finish this problem. So let's go to the next step. Let's distribute this 4. 4 times 2 is 8, plus 4 times the square root of 3. Again, we can't do anything with that, so we just write it next to each other as 4 square roots of 3. Now let's go to the bottom and let's FOIL this out. So start with first times first. 2 times 2 is 4. Now go to the outside. 2 times the square root of 3. Again, you have to just write it next to each other and write it as 2 square roots of 3. Now go to the inside. Negative radical 3 times 2. Well, it's going to be negative. Stick the 2 in the front and the radical 3 behind. Again, don't try to multiply the numbers. One's under a radical, the other one isn't. So it's just a minus 2 radical 3. And then let's do last times last. Negative times positive is negative. And the square root of 3 times the square root of 3 is the square root of 9. They have the same root, so you just multiply the numbers underneath to get 9. Now we want to simplify. I don't see anything that I can do to simplify the top. So let's just bring it down. Don't try to combine these together. They're not like terms. So, and I don't see any simplifying we can do with it. So we're going to bring it down. But I do see some things that we can do to the bottom. Couple things, actually. Look at these 2 radicals. So I told you that something interesting about a conjugate is that whenever you multiply conjugates together, like these, the radicals go away. Here's how that works. I have a plus 2 radical 3 and a minus 2 radical 3 now. These are like radicals, same root, same radicand. If I want to combine them together, I subtract the coefficient. So I would do 2 minus 2. But 2 minus 2 is 0. 0 times anything is 0. So what's happening here is they're canceling each other out. Adding a 2 radical 3 and subtracting a 2 radical 3, they're undoing each other. They cancel each other out. So they go away in the problem. Okay, so let's bring down this 4 in the front. That's still there. These canceled out, and then I have a minus square root of 9, which is a 3. So I now have 8 plus 4 square roots of 3 all over 4 minus 3, which is 1. Now, anything over 1 is just itself. So just as in any other algebra problem you've ever done, anytime you're dividing by 1, it's just going to be itself, and you can actually take that over 1 out. You don't have to put it. If you leave it, it's not wrong, but you don't need it. So you can take that out and just write your answer like this. This is what we call rationalizing a denominator using a conjugate. And this is what you have to do anytime your denominator has more than one part to it, if there's 2 things there to get rid of. Okay, I know that, there goes my dog, sorry. I know that I'm probably close to reaching my 30-minute time limit goal. I try to limit these to 30 minutes. I know we're probably close to that already. However, because I know that this is a little trickier than some of the other stuff we've done, it's starting to get a little bit harder, I know. I'm going to do one more for you. And there's a whole bunch of examples in the book, so if you need more examples, you can look in the book and get a bunch more. But I would like to do one more with you in this video, just to show you, get a little bit more practice in together. And then if you want to look at some more in the book, you can look at some more in the book, or just try practicing some in the assignment and see if you can get the right answer. I'm going to look at example 7 really quick. So I'm flipping the page. I'm going to example 7. It's 5 square roots of 2 over the square root of 7 plus the square root of 2. Okay, so big problem here, right? We have this fraction. There's 2 radicals in the denominator. We got to do something about that. We've got to get rid of those radicals in the denominator. And it is more complicated because there's not just 1 radical, but 2. So I can't use that first method that we learned, where we just multiply the radical by itself to get rid of it, because there's 2 radicals here to get rid of. So that simpler method no longer works. We've got to go to something a little bit more complex, and what you need to do is multiply this by its conjugate. And its conjugate is going to be the square root of 7 minus the square root of 2. This is going to become a FOIL problem. I'm going to have to FOIL that out. Now don't forget also that whatever you do on the bottom, you must also do to the top. So we have to multiply both the top and the bottom by the square root of 7 minus 2. Rewrite it exactly the same way, but change the sign in the middle. If this is a plus, this becomes a minus. If this were a minus, this would become a plus. You just change the sign. And now we're going to do the same thing we did in the last one. We're going to distribute the 5 square roots of 2, and we're going to FOIL the bottom. Okay, so let's start with the top. 5 square roots of 2 times the square root of 7. If that confuses you, just remember there's an imaginary 1 in front of that radical. So if you multiply the like parts, 5 times 1 is 5, and radical 2 times radical 7 is radical 14. Multiply the numbers underneath when you're multiplying. Okay, bring down the minus, and then do the same thing here. I have an imaginary 1 here. 5 times 1 is 5. Radical 2 times radical 2 is radical 4. Multiply the numbers underneath. Now let's FOIL out the bottom. So radical 7 times radical 7, that's first times first. That's going to be your radical 49. Multiply the numbers underneath. Now let's go to the outside. It's a positive times a negative, so I know it's going to be a minus. And radical 7 times radical 2 is radical 14. Multiplying the numbers. Now let's go to inside times inside. That's another radical 2 times radical 7, but it's going to be positive this time. So this is going to be a plus radical 14. And now do last times last. Positive times a negative is negative. And negative 2 times, radical 2 times radical 2 is radical 4. You've done basically the work at this point, but there might be some simplifying that you can still do. You always want your answer to be completely simplified. So let's see what else we can do to finish up this problem. I see a square root of 4, so I know I can take the square root of that and let that become a 2. And the 5 and the 2 are going to get multiplied. Okay. 5 square roots of 14, I don't think we can do anything with that. 14 is not a perfect square, and it doesn't have a factor that's a perfect square. So this 5 square roots of 14 we're just going to bring down. Bring down the minus, and then the square root of 4 became a 2, and then the 5 and the 2 get multiplied. So that becomes a minus 10. Now let's see what we can do on the bottom. There's actually a couple things you can do on the bottom too. The square root of 49 is going to become a 7. The square root of 4 is going to become a 2. And look at these two middle terms. I have a minus radical 14 and a plus radical 14. That's going to cancel out. Okay? Anytime you have a minus and a plus of the same thing, they cancel. So once again, because I'm multiplying by the conjugate, that radical in the middle cancels out and goes away. And you're left with just a 7 minus 2 on the bottom here. So that long, complicated thing is now just a 7 minus 2. Which we can also do something with. So let's keep going. So we now have a 5 radical 14 minus 10 over 7 minus 2 is 5. Now, I know you're probably looking at that and thinking, oh my goodness, there couldn't possibly be anything more that we can do with that. And you're almost right. Don't try to combine the top. They're not like radicals, so you can't do 5 minus 10 and try to combine that together. That's got to be left. Not a whole lot more that we can do here, but there is actually one more thing that we can do to finish simplifying this answer. Look at your numbers outside of your radicals. You have a 5, a 10, and a 5. All those numbers are divisible by something, the same thing. So this is a fraction. Even though it has a radical in it, it's still a fraction. And you still want to reduce and simplify this fraction as much as you possibly can. If there is a number that you can divide all of these numbers outside the radicals by, you need to do that. So they're all divisible by 5. So what you need to do is go through and divide each of these numbers by 5. That will give you a final answer. Okay, so let's see, where am I going to try to fit this in at? I'm going to put it real small down here, hopefully you can see it. So 5 divided by 5 becomes a 1 in the front, which can just drop out and go away. So that really just becomes a radical 14. Minus 10 divided by 5 is 2. Over 5 divided by 5 is 1. Okay? This became a 1 and dropped out. 10 divided by 5 became a 2, and 5 divided by 5 became a 1. Now, just like the last problem that was over 1, yes, if it's over 1, like the last one and like this one, you can also take that over 1 out. You don't have to have it in there. So, final answer, square root of 14 minus 2. I took out the 1 in the front of the radical 14, and I took out the 1 that was underneath. Now, I know the last two problems we've done all had a 1 in the denominator. They were all over 1, and we dropped it out. But let me just warn you, they don't all necessarily work out that way. So you might have an over 2 or over 3 or over 4, and that's okay as long as it is simplified as much as you can simplify it, and as long as there's not a radical in it. Okay? No, you cannot have a radical in your denominator, but you can have a whole number. You can have a 4, 5, 6, whatever. So don't just assume that all of these are going to wind up with 1s on the bottom, because they won't necessarily. Okay? Just the main goal is to not have a radical in the bottom. That's what you're looking for. And of course, you want your answer as simplified as you can get it. Okay? All right, so I've done 2 of these. I know they're kind of long. I know they're kind of time consuming. This video is probably really long. Remember, if you get bored with it, you can always pause it and come back to it. If you need to break it in half and watch half of it and then come back and watch the other half, you can. You can rewatch these videos if you need to rewind or go back or watch it over. So work on these, practice the assignment that'll be coming out tomorrow. If you're having problems, if you're checking in the back of the book as you go and you're having problems, email me. Rewatch the video. Okay? All right. So good luck, and I will talk to you guys again soon.